So how do you actually, scientifically, measure something you can't see or touch, like customer loyalty or a company's reputation? It's a massive challenge for businesses, but researchers have this incredibly powerful way to model what's going on inside our heads. Today, we're going to pull back the curtain on that exact method. Here's the game plan. We'll kick things off with why we even need these models. Then I'll introduce you to the tool researchers use for the job. We'll see how a model gets built, look at the numbers it spits out, and, this is crucial, we'll do a reality check. Finally, we'll see why this whole process is so important for making smart decisions.
Okay, let's dive right in. Here's the core problem. You can't just go up to someone and ask, "Hey, on a scale of 1 to 7, how loyal are you?" and expect to get a scientifically useful answer. I mean, abstract ideas like loyalty are way more complicated than that. They're all tangled up in this web of other feelings and perceptions. To really get it, you need a model.
Let's just use this as our example for today. Imagine a company wants to boost customer loyalty. Okay, great, but where do they put their money? Should they focus on being seen as more competent, or maybe more likable? Or is it all about customer service? If you bet on the wrong thing, that's a ton of money down the drain. You've got to know what really moves the needle.
And that's the key right there. The answer isn't hiding in a single survey question. It's in understanding the entire system of ideas. It's about creating a kind of map that shows how one concept, say likability, flows into another, like satisfaction, which in the end, hopefully, leads to loyalty. So, to build that map, researchers have a go-to tool. It's a statistical method called partial least squares structural equation modeling. Yeah, it's a mouthful, so everyone just calls it Pls-Sem. And it's designed specifically for this, modeling these complex relationships between the stuff we can't see and the stuff we can actually measure.
And it all boils down to two fundamental building blocks. On one side, you've got latent variables. These are the big, abstract, kind of fuzzy ideas, like company competence. You can't measure it directly, so in a model, we draw it as an oval. Then, on the other side, you've got the observed variables. These are the actual concrete questions you put on a survey to try and capture that big idea. And we show these as rectangles.
So when you put it all together, the ovals, the rectangles, and the arrows connecting them, you get what's called a path model. And really, the best way to think of it is as a blueprint for your theory. It visually maps out the structural model, which is the relationships between your big ideas, and the measurement models, which show how each big idea is being measured by your specific questions.
So how does this actually happen? How do you go from a simple theory floating around in your head to a testable blueprint like this? Let's walk through it.
Honestly, it's way more intuitive than it sounds. First, in a program like SmartPLS, you literally just drag your big ideas, your latent variables, onto the screen as ovals. Step 2, you draw arrows between them to show how you think they're related, what causes what. And finally, Step 3, you link your specific survey questions to the concept they're supposed to be measuring. That's it.
So for our company example, the theory, our blueprint, is pretty straightforward. We're guessing that a company's competence and its likability are both going to lead to higher customer satisfaction. And then, it's that satisfaction that's the real engine for creating customer loyalty. Boom, we've just drawn our blueprint.
Okay, now for the really fun part. Once that blueprint is all drawn up, we feed it our survey data, we hit the big Calculate button, and the software tells us just how strong every single arrow we drew actually is.
And a number like this pops out. This is called a path coefficient, and it tells us the strength of a relationship. So in our model, the direct link between customer satisfaction and customer loyalty is 0.504. But what does that actually mean? Is that big? Is it small? We need some context.
And here's where the story and the data really comes to life. When we look at all the factors that influence loyalty, customer satisfaction is by far the biggest driver. Company likability has a pretty solid effect too. But look at company competence. Its direct influence is almost nothing, 0.009. This is a huge insight. It tells the company that just being good at what you do isn't enough to make customers loyal.
We also get another value called R². Think of it like a report card for your model. It tells you how much of the thing you're trying to predict is actually explained by your model. So an R² of 0.562 means our little blueprint here successfully explains 56.2% of why customer loyalty scores go up or down. That's actually a pretty powerful model.
But hold on, we can't just take these numbers and run off to a board meeting. Getting numbers is the easy part. The hard part is knowing if we can actually trust them. So before we do anything else, we have to run a serious reality check to make sure our model is both reliable and valid.
The standard process for this is a two-step evaluation. First, you check the measurement models. The big question here is, are our survey questions actually any good at measuring the concepts we think they're measuring? Only when you can say yes to that do you move on to step 2, checking the structural model. That's where we ask, okay, can we really trust the arrows we drew between the concepts?
And this all comes down to a really core idea in research. As the saying goes, reliability is a necessary condition for validity. What that means is, if your measurements aren't consistent and dependable, they have absolutely no chance of being accurate. Reliability has to come first.
So the first check is for what's called indicator reliability. Basically, we need to know if each individual survey question is strongly connected to the concept it's supposed to represent. We look at a score called an outer loading, and a common rule of thumb is that it should be above 0.708.
Now you might be thinking, why that super specific, random-looking number? Well, it's not random at all. It's a bit of statistical shorthand. If you square 0.708, you get about 0.50. So this rule ensures that our abstract concept explains at least half of the reason people's answers to that question vary. It's a check for a really meaningful connection.
Next up, we check for something called discriminant validity. This sounds complicated, but the idea is simple. We just need to make sure our concepts are actually different from each other. You know, that our questions about likability aren't accidentally measuring the same thing as our questions about satisfaction. We use a metric called HTMT for this, and if the score is below 0.85, we can be confident our concepts are distinct.
So after all that, why do we go through all this statistical heavy lifting? Why does all this rigor matter so much? Because this process is what turns a spreadsheet full of data into a genuine, strategic, real-world insight.
I mean, think about the journey we just went on. We started with a simple guess and turned into a hypothesis we could actually test. We went beyond just seeing that two things are correlated and started telling a plausible story about what causes what. We took raw, messy data and forged it into a sharp, strategic insight. That initial blueprint we drew? It's now a stress-tested, trustworthy plan of action.
And this brings us right back to our original question. Because we did all that rigorous validation work, the company now knows something with a high degree of confidence. It knows that investing in being more likable and ensuring customers are satisfied is a much more direct, much more effective path to loyalty than simply shouting about how competent they are.
This method is just so incredibly powerful for digging into the hidden drivers of how we think and act. So I'll leave you with this final thought. If you could use this approach to model the hidden forces behind one single decision in your own life or your work, what would you choose to understand?